programming language, not Postgres. I'm a large contributor to the language itself, and I've been using it for maybe a year and a half. I wrote the Postgres driver for it, and the Postgres driver I wrote for this is very fast. I haven't done some benchmarks lately, but it was like on par with the C native libpq, and that's mostly because Crystal itself is so fast. But what is Crystal? It's a programming language that's very Ruby inspired, but it's all completely statically compiled with LLVM. For those of you not aware, LLVM is a compiler toolchain that is used primarily for building iOS applications, and all of the C compiling you do on your MacBook is done with LLVM and Clang. I think also PlayStation uses it and some other things, but it's a very it does some very advanced optimizations during compile time. Crystal is completely self-hosted. That is to say, the compiler itself is written in Crystal, the standard library is written in Crystal, and so it's very easy to go in and poke around and see exactly how something is done. This is opposed to Ruby, where the compiler, the parts of the lexicon, most of the standard library is in C. With this being in Crystal, you can really, it makes a lot of sense. It's very easy to contribute to, and if you're running into some rough edges, it's very easy to patch around them. Though I think the biggest difference between Crystal and Ruby is that it's completely statically typed, and it has completely static method dispatch. So there's no runtime dynamism that you might be used to in Ruby. Everything is static. But it still feels very Ruby-ish. I'm going to show you some examples, as we get going, but it doesn't. I've tried some other statically compiled languages, and this always feels like you're kind of fighting the type system coming as a Ruby developer. But with this, I feel right at home, and it's very, very fast. So here's two programs. On the left here we have Crystal. On the right we have Ruby using Sinatra. On Crystal we're using a framework called Kamal, which is very unabashedly Sinatra-inspired. You can see almost the same code. But when we run it through a benchmarking program, you can see here that we have half a millisecond versus 4 milliseconds, so an order of magnitude faster. But the memory usage is 2 orders of magnitude less memory, and we're just getting incredible performance with a very small amount of resources because it all is ahead of time compiled. Another exciting thing is the Sidekick author, Mike Perman, I don't remember how to pronounce his last name. He ported over Sidekick, and within 3 days of not knowing the language at all, was able to port a minimal working set of Sidekick. For those of you who know where Sidekick is a queuing service using Redis and Ruby. And he says here that the code is nearly identical, except that it's 5 to 10 times faster in production. And so that's pretty exciting. I also put in some bad jokes. So I never wanted to believe that my roommate was stealing from his job as a road worker. But when I got home, all the signs were there. And so this is to show off. So this talk here is a live programming thing, so you can edit the code and get it to run. And so I'm going to show you some examples live as we go. So the similarities here. This works exactly the same as it does in Ruby and Crystal. We have enumerable methods, we have blocks, we have much of the standard library, we have ranges and so on. So here we go, 1 to 5, sort it backwards and then reject it, the ones that are even. We can even do here instead, change it to be reverse, and I'm pretty sure that'll work. Yeah, so that's the same there. You have classes, object-oriented programming, implicit return. This is all pretty much the same. You'll notice here, one thing that did sneak in is there is a little bit of a type annotation there. Don't worry, it's not that bad. But we have instance variables. We have calling, initialize, and all this. This is all very much the same. One thing that's very nice. Some people like to don't like monkey patching, but the fact when it is available as a tool, it is sometimes very handy. And so here we were able to redefine something later. This is also very nice because, as I mentioned before, that Crystal is self-hosted. if you find something in the standard library that you do need to monkey patch over, there's no performance penalty to that. You get all of the same optimizations that go across the standard library in your code. LVM is able to look at those things together when it optimizes your program, and so you get you don't pay any performance penalty for if you do have to reach in and monkey with something a little bit. You get modules with mix-ins. You already have extend, you have include, just the same as Ruby. And one thing that's very nice is that you have a lot of the same idioms as you have in Ruby. And so you have here question mark methods look the same, a trailing conditional there. And one of the things I found, when I started working with Crystal is that, sure, like learning the syntax of a new language, you can do that in a week or a couple weeks. Like that's not really the problem. But learning how to structure your programs, where to put the files, how to think about your programs, that takes years to become idiomatic even in a new programming language, even if you're an experienced programmer. And the fact that this superficially looks so much like Ruby, I'm assuming that a lot of people here are Ruby programmers. I'm sorry if that's not the case, but you can take all that knowledge with you as you move forward, and that is very nice. Yeah, and like memoization, the or equals and stuff, that works the same. And even has a spec framework, which this is very nice. Right out of the box, you can has a spec framework built in. This thing here doesn't do the syntax coloring from the ANSI shell, but you can see here that this feels quite at home. So a couple of my friends asked me if they wanted to go camping at Yosemite with them, but I said no because it seemed too intense. So is this really just the same thing as a compiled Ruby? Like, no, there are some differences. I'm going to start out with some small differences. This example here, this is the same as Ruby. So you have initialize with a name and a citation. One of the little nice things that you can do is we can delete this and just put an @ sign in front, and that means the same thing. And so that's sort of like little boilerplate stuff of your classes where you're just like, I'm going to put this as an instance variable and put this as an instance variable. This is a small thing, but it's a nice thing. And just as an aside here, because it's a statically compiled language, you can use some of the tools built in to sort of peek at your classes and get some information. And a lot of editors have this now built in, so you can say, okay, like for this class, how much size does this take up? What are the properties? The strings take up 8 bytes, and it's a pointer off to where the string lives. You can see the hierarchy and all that, and that's kind of a nice thing. One thing I like a lot is toproc is a little bit fancier here. And so I have this array of 3 strings. I can call upcase on here. You see the main difference here in Ruby is this is a period instead of a colon, which runs about 50 times faster because it takes up half the ink. Thank you. But what is nice is you can actually chain the calls. And so I can reverse it and then upcase it, or I can even chain calls that take some parameters, so I can split it across, sort the individual characters and join it. And so this is maybe a little bit too much to put into a single line, but it is kind of nice that you can do a little bit more than you can with Ruby's symbol to proc. I saw a bicycle fall over once while I was walking down the street. Not even going to say that one out loud. I'm sorry for doing two jokes in a row, if anyone is trained in ballet. So let's get into more of the types. So look at this example right here. I'm not saying any type declarations in this method. I'm just saying it's something that doubles something that calls asterisk times 2. So I call it here with the number 3, and I call it here with a string. And the result is 6. 3 times 2 is 6. And this doubles the string. And this is the same as in Ruby. But when I ask what the type of the language, what the type of it is int32 in string. And so what's actually happening under the scene is Crystal is creating 2 copies of the language. Because I said it was statically dispatched. I said everything was statically compiled. How is it getting a single type out? It's because it copies the method twice. And then it knows at compile time, this one's going to call the first version, and then the second one's going to call the second version. And so that all works fine. But this is a little bit more complicated example. depending on what I pass into this method, if I pass in a number bigger than 10, it returns just the number itself. If I pass in something smaller than 10, it just returns a string too low. It's like a very bad validation method. And so if I call it here with 15, when I ask it its class, I get int32 as you'd expect. But when I use that type of method, this is not so the class is the runtime type, what's happening as the program's running. The type of is the compile time type. And you can see here what it did is it created a union of those two types. Because it can't know, at compile time, it can't know what's going to be spat out. And so it creates a union of those two types. Now, as we saw before, the multiplication method is defined on both. And so this code here works. We double it to be 30, and we double the string to be too low. But if I go and call the plus method, there's going to be a problem. And that's because while string does define here, the error message says it does define plus if the other argument is a character or another string, that would be fine. But what here I'm passing it as a number. And so this program fails to compile. And so, okay, so what if we get rid of this else? Now it's not returning the string, that should be fine. But now what previously worked now fails. Because this method up here, if it doesn't return the integer, it returns nil. And there is no method that is asterisk on nil. And I'm sure, if you're a Ruby program, you've seen all the time, undefined method on nil class. This is the same thing, but caught at compile time, which is much nicer. And there's no, like some languages have special null types that you have to do special null checking. This just falls out of the fact that it automatically creates a union of whatever types of things that the method can return. And so the way we can fix this is if we say, okay, I'm going to promise to only call this if it's defined. And then, in this case, since it knows that this isn't going to be executed, it knows everything inside here is only going to be an integer on the inside of the conditional. And then everything works normally. And there's other ways you can get around it if you forcibly cast it down. Ignore that. That probably should work. Sorry about live coding. And so there's a couple other ways you can get around and say, like, I promise this is not going to be nil. But I think this is one of my favorite features is you get all these sorts of checks and like you get it at compile time, and so you know you're not going to get an undefined thing at runtime, which is quite nice. Another thing that's a little nice is if you're developing any sort of like library or framework and you want the arguments to be kind of nice for the user, you see this a lot. Rails does this sort of thing a lot, where you can pass any sort of arguments in, but then you have to switch on the arguments. Like this is a contrived example in Ruby, as a short example, but I see some of this, somewhat frequently. Instead in Crystal, if you want, you can say the compile types up top, and then it'll automatically route to the right method. And not only do you get better sanity, you know exactly what those arguments are going to be inside there. It is also faster because you're not doing that check at every single invocation. And one thing that's I've used this a little bit. I thought when I first saw it, I thought I'd be using it a lot more, but it turns out I only use it every now and then. Is abstract types. And so here, this is the classic inheritance example of animals and the kinds of animals there can be. And then a person takes a name and has a pet. And if I try and get my pet to talk, it says right here that it's not going to talk because the animal class doesn't have the talk method defined. And so that's nice, because it knows that anything that can be passed in as an animal has to have that method defined. If I change this to say that it's an abstract class, and I promise I'll never instantiate an instance of animal, then everything compiles fine. And you get sort of that thing. And you can also, if you want, inside here, you can say def talk, abstract def, and then if one of these no longer defines it, the program won't compile because it knows that one of the children didn't meet that protocol. So one of the things that is a little bit so I think those are all like nice things about the type system that are there for you to take advantage of, but aren't like that cumbersome. The containers, unfortunately, is a little bit more cumbersome, and so here I have a container that I'm defining this at compile time, so it knows that this is going to be an array of either strings or characters. And if I put something in backwards for the first one, it'll let me put it in backwards. But then if I try and call something on that first one, it's not going to work because, again, the plus method isn't defined on both character and integer. But it'll let me put it in backwards, which is a little bit annoying. If you define these tuples, then it knows this is the same thing as an array, kind of, but it knows the position and what the types are. And so this thing works, but it won't let me put something in backwards because of the types. But the annoying thing is you can't just create an empty array anymore. You have to say like of string. And so this is so you get that nice safety, but this is the one sort of price you have to pay is you can't just create an empty array. You have to say, I promise it's going to fill it with these sorts of types. And that isn't as nice, but I think it's an okay trade-off. But everyone knows the worst nails to hammer, of course, are your fingernails. Thank you. So getting into a little more features that make it just as nice to program in this language as Ruby are these sort of macros. And so I said everything was static time compiled and there's no runtime dynamism. But with these macros, you can get sort of the same sort of things as, I make a library and I want to say, you have some sort of nice API to say this class, acts as whatever. So that, since there's no, like Ruby does that with metaprogramming, but with Crystal you do it in the macros. And it's just something that happens as your program is compiling. And at first I thought this would be somewhat limiting. But actually when I thought about it and looked at all my programs these days, all of the metaprogramming is happening as the program boots. Like after my program's been running for 5-10 minutes, I really don't expect anything to be defined that late in the stage of the game. And that would be really hard to reason about if it actually, as the program was running, it was redefining things. Like everything I see these days, the metaprogramming is at boot time, and shifting that over to compile time works out for almost all the cases. And so this is sort of like a little templating language that you get. This is how this would be the same as like add or reader in Ruby, defining getters and setters. But you can also do some cool things like shelling out. And so you can use backticks and during the compile time shell out. And so this is a method that burns in as your program is compiled the date. And so as I run this program over and over again, you can see that the first line doesn't change, but the second line where I shell out during runtime does change. So so you can do any sort of things. I was toying with the idea of doing an ORM and having during compile time it connect to the database and get the fields. I think that's a little too cute, so I probably won't do it, but it's possible. I started running out of jokes. So what is base64 encoded? This text right here. Sorry. So when I first started doing Crystal, I needed a project. And so I wrote a Postgres driver. And Postgres comes with a library called libpq that takes care of connecting to a database, running queries, and all that sort of thing. So the easiest way to start was to just link against libpq and have that do all the work. I've since replaced the driver to speak the protocol natively, and it's quite faster because of that. But this entire 12 lines here at the beginning, unless if you make it, actually, made it so it's a little more readable, that entire program here that you see is from scratch. All you need to link against libpq, connect to the database, and run a query. And so you see here, if I go down a little bit, it's like, this is a live query running right now. This is compiling, linking against libpq, connecting to my database, and issuing this query. If I change this to be version, it'll change the result here to say the current version of Postgres on my machine. And being able to link against the wide world of C libraries with this small amount of code is really cool. So all I'm doing here is I'm mapping between whatever the exported C functions are to what I want them to be called in Crystal, and then this is a lot of type stuff, but it's just doing the mapping of what the Crystal type is to the C type, and like there's not a lot there, and so this is one of the first things that impressed me about the language. And you can see there's a lot going on here. It's mostly not important, but you can see here's the linking step that it does. And then when you look at the libraries it's linking, it is indeed linking against libpq. This is a little bit more ugly as an example, but one of the nice things, a common pattern in C libraries is you pass in a pointer, and then the function manipulates whatever's at that address, and then it doesn't return anything, but you get that thing back. All of that is put into a nice little helper thing here called out, and this will, in Crystal, automatically define that variable of the correct type, populate it, and then you can use it later. And this is actually the code to link against libpcre to do the regular expressions inside Crystal. So I recently had gutters installed, and the carpenter said it was on the house. It's nice. So one of the nice things about this being a compiled language is the profiling is a lot nicer. I don't know if you've ever tried to run Perf or this is instruments built into OS X against dynamic language, but all you ever see is all of the VM internals of operating on this node or that node. Here you can see like I'm getting actual the bite-sized method in here. I'm seeing my classes inside the profiler, and like this is not anything new to C programmers, but getting this in a higher level language makes debugging this sort of thing, performance problems, really easy. And I don't know if you haven't played with Perf or this instruments on OS X, it's really awesome. You can click on, it drives down to the assembly. I learned this tool. I wrote a program to manipulate all of my Git SHAs to start with Cafe. So every commit I've done for the last 3 years has started with CAFE. And I wanted to make sure that, since I realized I was going to be running this for the rest of my life, I wanted it to be fast. And so I did a lot of C profiling to make it really fast. And I was just blown away about how powerful this tool is. So this is a true story. The gutters one, it wasn't true. I don't have a house. I don't have gutters. But I was making coffee, and I was trying to weigh out the beans. Like normally I just eyeball it, but this time I was like, I'm going to do this right. I was weighing it out. But I accidentally hit the scale tare button, and so I lost all the measurements, and I was just like, man, this was a terrible mistake. So just a little bit of miscellaneous things that are nice. Similar to Ruby, there are classes and structs, but unsimilarly, they behave exactly identical. So I can change this to be struct, S-T-R-U-C-T, struct, and it'll behave identical. The main difference is classes are allocated on the heap, and structs are allocated on the stack. And this took me many years to understand the difference between these, so I'm going to explain it. Sorry for those, if this is remedial for some people, but the heap is the part of your program that is long-lived memory that is the thing that's sitting out there, and that's what your garbage collector is going to have to go through and clean up over time. This is where your leaks are. On the stack, this is just as you call a method, it's just local to that single method, and then once that method calls, the memory just leaves there and the pointer goes back, and so it doesn't have to worry about that. Like, no allocations have to happen, but you can't share that between things. Being able to control this sort of thing and have, okay, these sorts of objects, I want them to be structs, and these ones I wanted to be, and don't have to worry about GC pressure, don't have to worry about allocation time, and then other things I'm going to pass it around, so I need to put them in the long-lived area. Being able to sort of control this, while maybe it's not as fancy as like Rust's memory model and all that, you can get incredible performance things by avoiding putting pressure on the GC. And so, but where the trade-offs, if I try and change the name here, so here, when it was a struct, I tried to change the name, and it didn't actually stick and change to Alice. But when it's a class, the change name method outside will actually work and change the name to Alice. So that's, if you can make something a struct, you can get things like, even inside Crystal, you can get things an order of magnitude faster, which is a nice thing, little dial to be able to play with. Another little sort of random thing, all of the I/O is asynchronous, and so that's when I got some of the big performances making my driver be native I/O. All the I/O to Postgres was asynchronous, and it could be a lot faster. And the other nice thing is, anytime you do like the string interpolation, what it's actually doing is using a string builder and putting it in, so you're not making lots of temporary strings. And so a lot of the I/O just natively in the language, it decomposes it to be more performant in the compiling step. It has a formatter, sort of directly stolen from GoFumped. Also stolen from Go, the concurrency model is coroutines and channel passage. There's a lot of the docs, and yeah, that's mostly it. If you have any questions about the language, like getting started, I'm always happy to help. This whole presentation here is a workbook, and so you can, if you install Crystal, you can download this and run it in the browser. You can start editing the code, which is, I think, a great way to start playing around with something live. And thank you very much.
I have 2 questions.
Sure, yeah.
So the first one is there any type to explicitly define, say, some sort of interface, or it's just the typing where you're actually expecting the possibility of markdowns?
Yeah, there's no like first-class interface thing. It's one thing you can do is if you make a module and have the types there and include that module, you can say that this method only accepts that module as a type, and that sort of gets you, I think, maybe the 80-20 on like first-class interfaces.
Yeah. And the union type, is that a first-class type you have? Like
Yeah. So yeah, the union type. So it'll automatically create union types when necessary, and you can also define. You can say alias. My type is a union of string and int, or my class, and then you can pass that around as a type.
Okay.
So you can alias and name it, and then talk about it that way.
So the last question is about compilation time. Like you guys are doing a lot in terms of type inference and all that.
Sure.
What is do you have like some benchmarks or anything? Place you can go look for those?
Yeah. So like just as a so like this is my Postgres driver. So now it's compiling. So this is a little slow, but then it just ran 100 examples, each of which hitched the database. And so that you saw there the compile time against immediately sized program. There's two compilation things. This is the unoptimized build. If you do -- release, that's when it kicks in all the LLVM optimizations, and that does take longer. But for like development mode, like this compilation time, I'm actually quite happy with. The booting time, like in development mode, the booting time is like often faster than like Ruby and bundler booting and requiring all my stuff. So I'm happy with that. I don't have any like raw numbers, but
I was just curious because it seems like the compiler's doing a lot. So.
Sure, yeah. So it's actually I think it's actually impressive how fast the compilation is. They're working on a project right now. Right now there's no incremental compilation, and they're working on that now. But I don't know what the ETA is on that.
What's the current adoption of Crystal? Are there any companies using it?
Sure. So I know of a small handful of companies that are using it for some of their. I don't know of anyone who's using it for their main product, but some people are using it for smaller services. The guy who wrote the micro framework is out of Turkey, and they're using it for something. I don't know exactly what. The other one here in town, Rainforest, is using it for their badges. I'm using it in production for, I don't have the internet on here, the hit counter on my professional website. Because I found out people were ad blockers were blocking hit-counters.com, and so I re-implemented it. But So that's what I'm using for it. But.
And you have like a roadmap for 1.0.
Yeah, so I think the incremental compilation is one of the big things that's before 1.0, and then the other thing is right now there is concurrency, and with the async I/O that helps. But right now you can't use threads. Like the GC is often another thread, but you can actually use multiple processors, and that that is unfortunate. But that I think they're going to work on that before the 1.0. But all of the early on there was some bigger changes to the language. Right now, in the last year, there hasn't really been that many huge breaking changes that were annoying, and so it's a good time to start poking around with it.
You guys have a notion of reference versus value types?
Right. So that's mainly the class versus struct thing. So everything's passed in by reference except structs, which are copied over, and that's why you can't modify them and expect it to work.
Does it reduce the number of tests that you need to write versus you write an application completely?
Yeah, I think somewhat. I mean, it didn't in practice reduce the number of tests that I personally write because I would just hope that I got all the type checking stuff right and then be surprised in production because maybe I'm not as thorough as I should be in Ruby. But it's more, one of the nice things is I can, as I'm refactoring and moving stuff around, I know instantly when it doesn't work. Because in Vim I have it set up to run the linter and the formatter right away, and just as soon as I save the file, it'll put on an error saying that this type is wrong. And so like the tests would show that when I tried to run that, but having that be like near instant has been very nice. Okay, thank you.